Addition is pretty simple, right? But what about adding fractions? Now that's a different ballgame. It's not quite the same, but if you stick with me, I'll help you understand how to solve fraction addition problems. So let's go. What's up, you guys, and welcome to Grip EDU. Hey, before we get started, make sure you hit that like and subscribe button so that you can get every one of our new videos and help others find us too. Today we're going to learn the very beginning of how to add fractions with unlike denominators. If you're already familiar with this skill and you think you're ready for some of the harder problems like this, then I encourage you to watch the Adding Fractions Level 2 video. But for now, let's start nice and simple. Let's add 1/2 and 2/5. Now, there's a great, big, important, never to be broken in a million years rule when it comes to adding fractions, and that's this. You can only add fractions if their denominator is the same. If their denominator is not the same, or another way of saying that is they have unlike denominators, then you need to do some work, and that's what we're looking at today. Let's take a look at these two fractions. What we're trying to do here is just combine these two amounts. Now, I can do that on this model here, but as you can see, there's no real way to tell what amount I just made. Not like this, at least. So what we need to do is find a way to change these fractions so that they have the same denominator. We're not going to change their value. They're still going to be worth the same, but we're going to change the numbers we use to make the problem simpler to solve. We're going to be creating equivalent fractions. And if you need some help with that skill by itself, click the link on the screen up here for a lesson on that. There's a few basic steps when adding fractions. Set up the problem vertically, find the least common denominator, create equivalent fractions, add only the numerators, and simplify if needed. First, we'll set up the problem vertically. You'll see why that's important in just a minute. When you multiply or divide fractions, you should set it up horizontally. But for adding and subtracting, vertical is the way to go. Now that our problem is set up, we need to find the least common denominator for the fractions that we're adding. Sometimes the least common denominator is referred to as the LCD or LCM, which means least common multiple, and they all mean the same thing, which is if you listed out the multiples of each number, the least common denominator would be the first number that they have in common. Let me show you. If I listed my multiples of 3 and my multiples of 4, what would be the first number that they have in common? Let's list our 3's, or at least the first couple. 3, 6, 9, 12, 15. These are just the answers to my times 3's, right? They're the counting numbers for 3. Okay, now let's do some of the 4's. 4, 8, 12, 16, and so on. Now, compare the two lists. Do you see any numbers that are in common? What's the smallest number that appears in both lists? 12. So the least common multiple, or least common denominator of these numbers would be 12. Now, let's do that same thing for our practice problem. Let's list our times 2's, so 2, 4, 6, 8, 10, and now let's do some times 5's. 5, 10, and oh, there's the match. Did you catch it? The least common multiple of these numbers is 10. So what does that mean? That means we're going to rewrite our original fractions, but this time we're going to write them as blank over 10 because we now have a common denominator. The next step is to complete the equivalent fraction. A good rule of thumb is this. If you change the denominator, you're going to change the numerator as well. So let's see. How did we change the denominator for 1/2? Well, to get from 2 to 10, we did times 5. And since I did times 5 on the bottom, I'm going to do times 5 on the top. 1 times 5 is 5, and I now have my equivalent fraction. For the other number, how do I get from 5 to 10? I can multiply by 2. 5 times 2 is 10. For this one, since I did times 2 on the bottom, I have to do times 2 on the top. 2 times 2 is 4, and now I have my other equivalent fraction. Do you remember the great, big, important, never to be broken in a million years rule with adding fractions? It was that you can't add them unless they have a common denominator. But guess what? Now we do. So it's time to move on to our next step and add them. When you add fractions, you need to remember this. Only add the numerators. Don't add the denominators. Keep those the same. So to add 5/10 plus 4/10, we're really just adding 5 plus 4. And that's easy. 5 plus 4 is 9. That's the numerator. The denominator will stay the same. Let's look at it with our models. We just turned 1/2 into 5/10, and we turned 2/5 into 4/10. We combined them to get our same amount as before, but now it's much easier to see that it's 9/10. The last step would be to simplify if needed, but this problem is already in simplest form, so we actually get to skip that step. If you want a refresher on how to simplify fractions or how to know if you're already in simplest form, check out the description box for links to those lessons. Okay, let's review those steps again. Set up the problem vertically, find the least common denominator, create equivalent fractions, add only the numerators, and simplify if needed. Time for some practice. Grab your paper and pencil, and let's go to the whiteboard. For our first practice problem, we need to set it up vertically, like this. Then we need to find the least common denominator. Now, some people do these problems and go, wait, can't you just multiply the two denominators together and use that as the new denominator? Well, the short answer is yes, but sometimes that's not the least common denominator, so you'll end up with some serious simplifying to do at the end. I recommend using the strategy that I'm showing you so that you can make sure you have the least common denominator and are working with the smallest numbers possible. Let's list out the multiples of our denominators. First, let's list a couple of the 4s. 4, 8, 12, 16. If you're wondering how many of them to list out, there's no perfect answer. I just recommend you do the first 3 or 4 and see if there's a match. For 6s now, let's list them. 6, 12, and oh, there's the match. Let's circle the 12s. So each new fraction will have a denominator of 12. Next, we need to create equivalent fractions. So let's fill in those numerators. Remember, if you change the denominator, you'll need to change the numerator as well. Let's look at how we got to our new denominators. For the first fraction, how do we get from 4 to 12? You do times 3. So let's do times 3 on the top as well. 3 times 3 is, of course, 9. Now for the other denominator, how do we get from 6 to 12? Times 2, right? So we'll do a times 2 to the numerator here, and we'll get a new numerator of 2. Next, we can add 9/12 plus 2/12. Remember to add only the numerator. So that makes 9 plus 2, which is 11, and the denominator stays the same. This is already in simplest form. For the next problem, I've already set it up vertically. So let's find that new denominator. We'll list out our multiples of each denominator. First, the 8s. 8, 16, 24, and we'll stop there. Now for the 4s. 4, 8, and hey, there's the match. Some of you probably already saw that one coming, so let's circle it. Our new denominator is 8. Next, we'll make our equivalent fractions. If I change the denominator, I need to change the numerator. But what do you notice here? The denominator didn't change. So guess what? Neither will the numerator. So 3/8 is going to stay 3/8. Now, we could have done it the longer way and just multiplied each side by 1, but that still would have gotten us to the exact same number. For the other fraction, how do we get from 4 to 8? We multiply it by 2. So let's do a times 2 on the top, which makes a new fraction of 2/8. Time to add. 3/8 plus 2/8 is 5/8 because we only add the numerators, and it's already in simplest form as well. If you're ready for the next level of difficulty, click the link that you see on the screen up here. For help on simplifying, I've got you covered with this video. Until next time, I'm Mr. D. Thanks for joining me.